Hey guys, this is Mrs. Harbin, and this is Pre-Calculus Chapter 2. This is all about polynomials, and today we're going to look specifically at relations. Our biblical correlation comes from 2 Chronicles 26:6, where Uzziah built towers in Jerusalem at the corner gate and the valley gate, and at the angle of the wall, and he fortified them. Now this is just a reminder that we see math all throughout the Bible, all throughout history. We know that math is useful beyond just the four walls of this classroom, and we want to make sure that you have the foundational pieces so that you can use math to go out and make a difference in the world. Our lesson objective is this. You, the student, will represent relations using circle mapping, sets of ordered pairs, function rules, and graphs, and use the vertical line test to identify functions. Now, all of this should be a review from Algebra 1 and Algebra 2, so we're going to go through it pretty quickly. First of all, a relation is any set of ordered pairs. A set of ordered pairs has an x and a y coordinate that we're going to use to plot points and graph on the Cartesian plane. It is not just a list of integers. In mathematics, many relations are described by an equation. Y is called the dependent variable, and x is called the independent variable. As a reminder, we're talking here about the Cartesian plane, which has four coordinates. This is our x-axis, this is our y-axis, and this x and y are actually called a lot of different things. X is also called the horizontal, while y is called the vertical. X is called the dependent, independent, y is called the dependent. We have x is called cosine, and y is sine. So we have lots of different names for this. We also just have x, and y is also described as f of x, or a function of x, which means that y is dependent on whatever value we have for x. And that's what we're looking at today. The set of x coordinates of the ordered pairs in a relation is called the domain, and the set of y coordinates of the ordered pairs in a relation is called the range. Basically, the domain determines how far to the left and how far to the right your graph reaches or your function reaches. And the range tells how high or how low your graph reaches, your function reaches. The domain can be a finite set of numbers. In this case, if we're looking at domain, the farthest left we go is -3, and the farthest right we go is 7. So our x's would be greater than or equal to -3 or less than or equal to 7. Or a domain can also be the set of all real numbers, where a line continues forever and ever and ever, and we don't have a definite ending. We have negative infinity to positive infinity, or all real numbers. The same can be said of our range. If we back up here, our range in this particular graph is as low as -6 and as high as 14. So y would be between -6 and 14. Or, again, it can be the set of all real numbers, negative infinity to positive infinity. A function is a relation in which every first coordinate, which is x, has one and only one second coordinate, y, associated with it. So for each x, there is only one y that it could be, and that is a function relation. We can use a vertical line test to go over a function that's already been graphed to determine whether or not it is a function. We can move an imaginary vertical line across a graph from left to right. If any vertical line touches the graphed relation at more than one point, the graph does not represent a function. So let's say you saw a graph. Let me switch colors here. There's our Cartesian plane, and you saw something that looks like this. As we move a vertical line going across, we see that it would touch the graph at 2 points. That tells us that that graph, this blue sideways C-looking graph, is not a function because a vertical line touches it at more than one place. Relations and functions can also be described by circle mappings, or sometimes called mapping diagrams, where we list all the domain values on one side and all the range values on the other side. You can see here that for this x value, we have two possible y's. that tells us that is not a function. Now, you can have the other way. You can have a y that goes to two different places. So, we said on the left here, that was not a function. However, we can have a y that goes to two different places. Let's take that out. And we can have a y that goes to two different places. So you could have a 1 that goes to 2 and 3, and that would still be okay. We cannot have a 3, an x value that goes to two different y values. That would eliminate that from being a function. Now that does happen, that sometimes you have a y go with two different x values. So keep on the lookout for that as we go through. Function notation is written like this. It's read f of x equals 3x minus 5. F of x is just our y value. Okay, x is going to be our input. We are going to input a value of x into our equation. We're going to plug in chug, and f of x, or y, is our output. It's what happens when we input different values of x. So function notation is just solving for y, but it's going to be written as this because it is dependent on what the x value is. When we want to evaluate a function, f of x equals 4x minus 7, for example, for a specific value, we're going to plug these two values into the equation wherever there's an x. So it should look like this. F of negative 3 equals 4 times negative 3 minus 7. Then we're going to use our algebraic operations here to solve, and we find that f of 3 equals negative 19. We don't have to do anything on this side. This is not a variable that we're trying to solve. So this stays exactly the same. F of negative 3 equals negative 19. When we plug in 0, we find that f of 0 equals negative 7. We now have two sets of ordered pairs. We have negative 3 and 19 from our first function, and 0 and negative 7 from our second function. We could then graph that to create a graph of our function. Sometimes you won't see f of x, you'll see g of x or h of x. All of those are functions. Again, we are not solving for g. We're plugging a number in. We're substituting in for x and then evaluating. In this case, we get g of negative 3 equals 18 and g of 0 equals 9. Ordered pairs are negative 3, 18, and 0, 9. See if you can evaluate this one on your own. Pause the video, come back and check your work. F of 1/2, when we plug that in, gives us 11 halves, which we will leave as an improper fraction. Don't turn that into a mixed number. Don't turn that into a decimal. Leave it exactly as it is. And f of 2a plus 1, again, anytime we see an x, we plug in that 2a plus 1, use the distributive property and our other operations, and we find that f equals 10a plus 8. Again, we're not solving for anything here. We're plugging in for x and evaluating, and this is what happens when we evaluate, and that's where we stop. If f of x equals 5x plus 3, find f of x squared and f of x minus 3. Pause, try these on your own, and come back and check your work. Hopefully you got 5x squared plus 3 and 5x minus 12. Sometimes, instead of being given the function and having to evaluate, we'll be given the ordered pairs, and we have to determine what the function rule was. A good way to do that is to start by plotting the points, which we've got over here on our Cartesian plane, and then determining both the slope and the y-intercept. The slope, remember, is rise over run, and we can figure that out using any two values. And the y-intercept is just where it crosses the y-axis. When we connect the points of the line, we see that it crosses the y-axis right here at 0. And our slope, we can do 10 minus 2 over 5 minus 1. and we would find that our slope is 2. Plug that into y equals mx plus b, and we get y equals 2x plus 0, or just y equals 2x. And we have determined the equation for this line. Today we represented relations using circle mapping, also known as a mapping diagram, sets of ordered pairs, function rules, and graphs. And we also use the vertical line test to identify functions. We're able to evaluate functions given certain x values, and we were able to determine the equation of a line from a graph using y equals mx plus b. If you have any questions, be sure to ask me next class.